What I should have done is, actually, I should have put that x on top of the 2 to write it like you might see it in a textbook. It would look like this: 3 cosine, or you might see it somewhere else, I suppose. X over 2 minus, excuse me, minus pi over 4 plus 5. If it's written like this, where the w is in there with the x, we can't accurately see what the phase shift is. And so what we need to do is we need to take out what is multiplying to x. And what is multiplying to x to give me x over 2? 1/2. Okay? Because think about it like this. If this x were to actually multiply to 1/2, the x would be under 1. It would be 1 times x and 2 times 1, which is why it would say x over 2. And actually, this is probably something you'd see more than you would see this. So, we're going to factor out a 1/2. After we factor out the 1/2, let's see what we get. We have 3 cosine. We factor out the 1/2. And then we have x minus something. And then we have plus 5. Okay, we had to find this something right here. We have to divide pi over 4 by 1/2. Now stay close with me. Watch. So take pi over 4 and divide that by 1/2. Pi over 4 divided by 1/2. When you divide by a fraction, what do? Multiply by the reciprocal. So I'm going to go pi over 4 times the reciprocal of 1 over 2, which is 2 over 1. So we can cross cancel here. That's a 1, that's a 2. And we would get pi over 2. So we have pi over 2 that goes in that spot right here. Pi over 2, that's going to be our phase shift. That's what's going to tell us what our phase shift is. Okay, let me get rid of this and we'll keep going. Now you guys know me by now. In order to graph trig functions, I like doing a cheat graph. The cheat graph is just a graph where you can change the values on the x-axis and the y-axis. And so we need 4 tick marks: 1, 2, 3, 4. And on that last one, we're going to put our period, whatever the period is. So we're going to have to take 2 pi, and 2 pi because that's the regular period for cosine. Take that regular period for cosine, and we're going to divide that by 1/2. Now remember, when we divide by a fraction, that's the same as multiplying by the reciprocal. Now if it's ever a fraction, I like to think multiply by the reciprocal, so I don't have to write the division parts. Now that's just a 2, right? So what's 2 times 2 pi?
4 pi.
So I get 4 pi. 4 pi is our period. And so I'm going to put 4 pi right here. And now divide the 4 pi into 4 sections. It would be pi, 2 pi, 3 pi, right? We're just going to count by pi's. So now that we have our period and we have our x values on our cheat graph, we can do the next thing, which is 3. You guys remember what the acronym was to help us remember? What? W-A. No, it's not racist. It's just how you probably would pronounce it with the H like that. So this was the W, or the omega. And this was the A, and this is your H, and this is your K. All right. So we did our W, we did the period, and now we're going to do the A. Now that 3 changes the amplitude of our graph. It used to be 1, now it's 3. That means it's 3 spaces away from the midline. I'm not going to say it's away from the x-axis because I don't know if this is the x-axis. I do know it's the midline though. All right, so we're going to say 3 spaces away, and it doesn't flip, so that means we're going to start right here. 1, 2, 3, and we put a dot right there, and then we go to the midline, then we go down 1, 2, 3, and then we go to the minimum, midline, and then max. That is our cosine function. Okay, so now we got a line drawn. Now we need to finish getting our y values over here. So we look at the k. The k is right here, the plus 5. What does that plus 5 do?
What the midline is.
It changes the midline. It moves the whole thing up. And so our midline is 5. So I'm going to put 5 right here. And then that would be 6, 7, 8. And 4, 3, 2. All right. So now the last thing that we have to take into consideration is the h. Now the h tells us the phase shift. Okay, and our h actually is not pi over 4 because we had to factor out this is our h right here. It's pi over 2. Now if it says minus pi over 2, what is our phase shift? Which way is it moving? It's moving to the right. So our phase shift would be plus, because it moves to the right, plus what? Pi over 2. Now, what does that change? Does it change the x values or does it change the y values? Let's look at a specific point. Oh, you guys think you know already, huh? Okay, here's the point right here. What is this point right there? What is this point? 0, 8. Okay, so you're saying the x number changes when you shift the whole thing to the right? The 8 stays the same, correct? So we would take the 0 and we would add pi over 2 to it, half of pi. And then we get our new point. Our new point would be pi over 2, 8. And that would go on the final graph, I guess you would say. So let's draw our final graph so I can graph it. Let's see, it would be like this. This guy right here. And we're going to go from 0. And then I'm going to do it like this. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's going to be 2 pi. And this right here is going to be pi. That's pi over 2. And this is 3 pi over 2. And then I'm scaling this one because this is the one I like to give you guys. I like to give you a graph with that scale on the bottom. And then these count like normal, like 1, 2, 3, normally. Okay, but since our midline is 5, we're going to count by 2s just so I can make sure I can fit it on my screen. So I'm scaling it myself, but we're going to say that it's a fixed scale. Okay. So that's -6, and then -8 would be right there. Okay, same as the top and the bottom. Okay, now, our first point is right here. Pi over 2, 8. So we go to pi over 2, and we go up to 8, and then we put a dot right there. Is everybody cool so far? All right, now let's go to our next dot. All right, and we'll see, like, this is kind of going to look weird over here. The reason why it's going to look weird is, look at our window. It only goes from 0 to 2 pi, but look what the period is over here. It goes from 0 to 4 pi. So we're really only going to be seeing this section of the graph. All right, so what's our next point? Our next point right here, what is that point? It is pi, what? Not pi 0. Yeah, it's pi 5. Okay, so it's pi 5. What do we have to do to this x right here? We add pi over 2, which would give us... No?
Just pi, right?
Pi plus pi over 2. What's 1 plus 1/2? 1 1/2 pi, right? Okay, but we don't have 1 1/2 pi here. We have 3 pi over 2. Let me show you how we get 3 pi over 2. We make this have a denominator, and then we make them have common denominators, so it's going to be 2 pi over 2. Is everybody still with me? Okay, and what do we get up top? We have 2 plus 1. What is that? 3 pi over 2. Okay, so this number right here is actually 3 pi over 2. Wow, that's a lot of like craziness right there. Hopefully you guys can see what's going on. Now that's 3 pi over 2 what? 5. So if I go to 3 pi over 2 right here, I have to go up to 5. Hey, let's draw our midline in there. That always helps. See the midline right there? Okay, so this is what our graph is going to look like. It's actually, we're only going to see that. I mean, we know it goes down, right? But do we know where it goes? Let's see, let's look at 2 pi right here. 2 pi is supposed to go down to this one, but wait a second. This one has to be shifted over, right? Has to, see, this would not be 2 pi, what's the y value there? 2. It's not going to be that because we have to add pi over 2 to that. And that will take this next point off our graph. So this is all we get to see. That's it. You could go farther. We could extend this right here. We could go out a little more, and we could say this is going to be, what would that be? What is 2 1/2 pi? That would be 4, 5. It'd be 5 pi over 2. We could go out to 5 pi over 2, which would be right there at 2. No, wait, where's 2 at? 2's right there. And then we could continue it. But I normally stop my graphs that I give you guys right here. Okay, that's the window I give you. So, I mean, you could go farther, I suppose. Now, I have a question for you, random. Are there any x-intercepts for this graph?
No, yeah.
What is the minimum? What is the lowest y value that this graph has? 2. Does it ever cross the x-axis? No. if it did cross the x-axis, then the lowest y value wouldn't be 2. The lowest y value would be 0 or a negative number.
So
All right, so you don't have to worry about the x-intercepts here because they don't exist.